Go ahead.
Hi, we're Dax. I'm Jessica.
Evan.
Alex.
This is our collaborative senior design project. I think we presented to most of you before with Peking University and University of Toronto. So DUX is the driverless urban car system that we've been developing for the entire last year. So the project scope was to build a global implementation system for autonomous vehicles. So not only just how the car looks, what it's powered by, stuff in the car, seating arrangements, all kinds of vehicle design features, but also all of the entire business and infrastructure aspects. What are the legal issues? How do we get these on the road? All the systems that need to be in place to actually have a system where, say, between 20 and 60% of the cars on the road are completely autonomous. So for spring quarter, we focus more on getting our paper finalized and submitted, and then some physical attributes of the actual project. So we have one of our little models that we're completing right now, which we'll talk about later, and some programming for this board.
So this is the timeline specifically for spring quarter. So what as Evan said, what we've been working on is finishing up our papers, collaborating with Peking University. Toronto finished about a month and a half ago, 2 months ago, so it's been a bit of a challenge there. And then from then, just finishing our small-scale model, which is kind of in parallel with what University of Toronto did. And now we have Peking University flying over 2 weeks from now to present at Design Review with us. So my focus in particular was on the aerodynamics of vehicle trains, specifically having 20 to 30 vehicles with really close following distances, which were more acceptable with autonomous systems. Something in the neighborhood of having like a 1 foot spacing distance, and what kind of aerodynamic benefit would you see and power savings over the course of a nationwide implementation. So this was something I did last quarter. I've run through a few other programs since then to compare results, and I work with my professor. And so this is just a brief overview of kind of the spacing that you'll see and flow design.
So one of the big things that we were looking at for vehicle training is aerodynamic efficiency, but also emissions reductions. On ICE cars, internal combustion engines, we have massive amounts of emissions. Switching to fully electric would eliminate all of those things. But you still have to meet the amount of electricity you need to produce. So looking into different ways to gain power for the cars. And then what sort of system and what redesigns do we need before an actual conventional vehicle to be implemented in an autonomous system. So in terms of autonomy systems as well as electric and aerodynamic systems.
So yeah, one of the things that PKU actually was trying to get us to focus on was viewing, switching up the seating arrangement, doing things that if you don't have a driver, things that you can now do, like having more of like a couch seating arrangement or anything more social. So the experience of getting from A to B is no longer I'm a passenger and I'm a driver. It's more we're in this together. What do we want to do to be efficient on our journey? You can do work, you could socialize, whatever it may be. You just don't have to be focused on driving.
When we thought about it, lots of people spend hundreds of hours every year commuting, and if you could manage that time better, do something else with it, maybe even just enjoy being on the road and seeing where you are, that could de-stress people a lot and help in a lot of ways. So some of the different vehicle design features that we had is movable seating arrangements, so that depending on the space in the car, if you want to load a bunch of luggage in it, maybe you can just scoot all the seats forward, or if you want to sit back and relax, you can just recline the seats entirely and just lay down. We'd also thought about implementing rotary drop doors, which is a system that was developed by JTech in the late 1990s, where the doors on the side actually, the windows slide into the doors and the doors rotate and slide underneath into the body, which is good for a lot of reasons because you can park really close to other people and get in and out of your car without a problem. You don't have to worry about opening your door and getting hit by any other vehicle. I think the only accident they had between two autonomous cars was one pulling out and sort of not knowing when the was going to be pulled out. So if you don't have the issue of doors opening with autonomous cars and the person might not seeing any issues there. But also it's good for things like handicapped people. like I'm sure all of you have seen, the extended and lowered vans to be able to get handicapped persons in and out. With this, with the door being able to just completely disappear underneath the car, it would be extremely easy to load wheelchairs or any types of luggage or whatnot into your vehicle.
So for putting all these cars on the road, we need like the infrastructure for it. So we looked into domestic infrastructure. Some of the things we'd have to would be like charging stations, how the cars would interact with each other, things like that. In Korea, they started creating an autonomous valet parking system that you basically had an app and you would just, they modeled how like the cars would be if you were just like want to get dropped off, like a taxi system, like things like that. You'd also be able to like watch your car as it parked, be able to see where it was, like if it was safe, things like that. For the charging, we figured the vehicles would have to know when they need to be charged because it'd be really inconvenient if you would have to like send it to be charged every time. So this way you can just get dropped off and the vehicle could just charge, figure out it had to be charged and just go to a charging station by itself. And this would be with induction charging so that a worker wouldn't physically have to plug in the car. It could just like roll over into a spot and charge and then leave when it has to leave. There's also maintenance. So ideally, these cars would be used for public transportation in a similar way to a taxi or Uber, but without the driver. So if there's no one inside, there's chances that it could get dirty or damaged, like people could throw up in it, people could just accidentally break things. There'd have to be some kind of surveillance or enforcement to decrease the damage. And also with everything being autonomous, there's a chance that traffic lights wouldn't be needed because you don't really need to stop people anymore. Like, if anything, they could like interweave through each other at intersections. Yeah. So we are planning to sell these to a variety of people. It really depends on how the car culture is in that area. So like in Orange County, it's a little bit more like everyone is more into owning their own cars. But in places like busy cities like San Francisco or New York, it'd probably be more for like public transportation. So the cities would own it. And you could like anyone could use it as a taxi service basically. So if you privately owned it, you could also opt to, if you're not using it, like send it out to have other people use it too.
Sort of an autonomous Uber at that point that someone else can rent your car for a certain point, have it drive them around, and then it would come back to you. So one of the big problems right now with autonomous cars is the legality and people being unwilling to change, unwilling to adopt systems that they might not feel safe about. Right now, the Google car, they've actually had to put a steering wheel back in due to the regulations. There's also an emergency stop button. I guess people didn't like that you could just sit there. There's a great picture actually of a mom and a kid sitting in the driver's seat, which to me is a great thing that anyone can say what they need to. It can take anyone around. But there are also other issues. Insurance is a multi-billion-dollar industry in the United States every year. And so, as there are many cars on the road, there will be crashes and accidents. And so, where does that liability go to? And that depends, like, just based on who owns the vehicles. So that's something that needs to be addressed. Does the city pay for insurance? Do we increase taxes as part of the system? And all kinds of different laws. And then there's a talk about there are a lot of limitations. So you currently also need to have a driver's license to still operate one of these vehicles. So we would need to push the laws in such a way that you might be able to get some sort of operator's license that you say with a forklift or something, you have training and whatnot, to be certified to operate these vehicles in a safe manner, but not require all of the monetary and time expenses that it takes to get a full driver's license. So at this point, if we're implementing the system, say 15 or 20 years in the future, we would mostly have to assume that these laws have been fully passed and that the autonomous systems have been in place for quite some time.
And in terms of the hardware, this is basically just a general overview of things that we've considered. Types of LiDAR, radar for following, infrared cameras, stereo cameras, just kind of a general idea of things hardware-wise that would be needed depending on how you set up the vehicle.
So for the control program for this whole infrastructure and the cars, there would be two types of communications. There would be one between vehicles, and then also one between the vehicles and data centers that we envision. So for the data centers, they would just send information to the car to let them, like, to make everything CAC optimized, to get them from where they need to be, to know where they are. And the vehicles, for their communication, it would just be like, make sure they're not crashing, make sure they know like what's around them. There are cybersecurity issues since it's all computer system, like people can hack into things like that. But I think right now there's technically cybersecurity issues with cars as they are, and it doesn't seem that big of a threat. So I think for now it's okay. And for the processing power, so currently Google's autonomous car reads data at 750 megabytes per second. There's also NVIDIA.
Yeah, the NVIDIA Drive PX, which I read a lot about several months ago, but really only just became an actual release system very recently. So they've been handing out developer packs as well, and looking to, sorry, that typo. It should be about $10,000 their entire system that they can implement on a car to make it autonomous. But they've been sending out developer packs to, I believe, Bentley, BMW, Rolls-Royce, Tesla, and perhaps Audi. So their entire Drive PX system is actually a deep learning system. So all the cars are connected to a neural network, which allows individual cars to recognize different shapes, and then for that recognition to spread throughout the entire system. So one car can take a picture of, say, something, someone can define what it is, and as it gets more and more repetition of that same image or similar images, the entire autonomous system will know which things are which. It's an extremely powerful system using mostly stereo cameras at this point to be able to detect all sorts of different icons. There's some great videos showing as your car drives down the street. You see what appears to be a person behind the car. As it emerges, it's a bicycle, and we can do its path based on a trajectory of the bicycle, say, crossing the street.
So for the regional distribution of the data centers, it just be based on like how many people are in this in an area. Major cities would get one, like more areas where like there's less people, less cars, it could be like spread out more. And in order for each car to be able to like go be in between data centers, we figured they would have to have some kind of fingerprint to track their identity.
So as of right now, what we're working on is, here is one of the test bodies that we made last night. It's of one of our, we have two small sail RC cars that we've, one will follow and form vehicle trains with, and one will lead with the GPS. And so this is one of, it's kind of a modified BMW body that we came up with last night. We'll have two of these. We're going to finish up our papers, send them to Peking University, and they'll be coming over, finishing up the paper and compiling everything into one and presenting our joint project in 2 weeks.